Jai Hind students, I welcome you all in the second lecture of telemetry principles, and as per the previous lecture, in the previous lecture we go through the basic definition of a telemetry principle, then we understand about the basic block diagram of a telemetry system, then we describe the various blocks, and in the previous section or the previous lecture we concentrate about only the transmitting end. In this particular lecture we are going to concentrate on receiving end, transmission medium, and also the factor influencing system and the classification of the telemetry system. So, starting from the signal transmission medium, as I told you earlier, in the telemetry principles we have two locations. One location is at the remote location and second location is at your place of working. So, between these two places there is some kind of medium present, and that medium you have to transmit the data through that medium. So, whenever the distance is small, you are going to use the wire or landline system as the transmission medium. That wired or landline system is some kind of copper wire link or optical fiber link or some kind of coaxial cable or some other kind of cable. It means in the transmission medium there is a physical structure between the transmitting and the receiving end. So, this type of telemetry is called wired telemetry, or if the transmission medium is wireless, it means you are going to RF channels, and you know that radio frequencies are EM waves, and that waves are electromagnetic waves, and this kind of telemetry system such as for example that is a satellite telemetry system that is going to use this RF link or electromagnetic waves for the transmission of the data. Similarly, the next point is receiving end. In the receiving end, what you are going to perform? You are going to perform actually the just reverse part of transmitting end, as at the transmission part you are going to perform some kind of modulation, amplification or multiplexing. So, at the receiving section you are going to perform that same amplification, then demodulation, signal conversion or demultiplexing. Now, why it is required? It is required because when the signal is coming from transmitter to receiver, you all understand through the communication system that noise is present everywhere. So, what is that noise? Basically any unwanted signal introduced in the system or interfere with the original signal, that is called noise, and this noise is required to be filtered at the receiving end, and after filtering it is required to amplify the receiving signal so that your signal can be used for the further process. After that amplification, filtering and amplification process, you are going to perform demodulation part. That demodulation is designed, the demodulator system is designed as per your the modulation technique used at transmitting end. If you are using amplitude modulation, you are going to use here amplitude demodulation or the frequency demodulation or the pulse demodulation. Then the signal conversion, because the next part or the next system parts, they are directly going to use that electrical signal, and as per the compatibility of this complete system, it is required to convert that electrical signal as per the compatibility of the next system. So, in the signal conditioning or then after that demultiplexing, in the demultiplexing what you are doing, that you are using the same channel for the n number of inputs or outputs, you are going to perform that demultiplexing, because now you have to select that particular channel on a particular point. That is why in the demultiplexing part, as per the definition of demultiplexing, one input many output and one particular output is going to be select as per the select line. Then the signal conditioner part, that signal conditioner part is going to perform some specific kind of operation of signal conditioning on this recovered data, because that recovered data or received data is going to be used for analog indication or maybe digital display or for the storage purpose in the digital storage, or the data processing part for the next kind of analysis, or the closed loop control. If you want to, as you know that in the instrumentation sometimes you use a open loop control, closed loop control, and that closed loop control is used to regulate the system or control the system. So, that is why as per the requirement of this end devices, you are going to condition the recovered signal. So, these are the basic building blocks of your receiving end part, and in the telemetry system these all are the three parts: transmitting end, transmission medium, then receiving end. So, combinedly these points are going to combinedly make a telemetry system, and that telemetry system design is also a very important part. So, in the next slide or in the next this particular part, we are going to study about the various factors which are going to influence the telemetry system design. As you are designing a telemetry system as per your requirement, you have certain factors which you always have to consider for the designing of a telemetry system, and that factors are: first one, accuracy. First one is accuracy. This is the primary criteria for any telemetry system design. If you are going to design a particular telemetry system, it must be accurate, because you are taking the data from a remote location, and if it is not accurate, then there is no need of that data. That is why the primary motive or primary factor is accuracy. Then second point, you have to identify that particular transmitting data is in analog in nature or digital in nature, because the complete system is designed for that particular kind of analog or digital system. Because for the analog system the requirements are other, as you cannot use the analog modulation technique for the digital data, or you cannot use the digital modulation technique for the analog data. So, you have to change. Similarly, for the digital data to be transmitted, if you are going to use a particular digital telemetry design system, then you have to use certain kind of system that are error detection, recognition, correction capability, all that points, and that all system are going to make system more accurate, because this particular point is related to the digital telemetry system only, and in the digital telemetry system error detection, recognition, correction capabilities, these all are required to make system more accurate, more confident. Then the bandwidth requirement, as I told you, noise is a very crucial factor which play a major role in the transmission of the data, and if you are not selecting the bandwidth appropriately or not designing the link between the system, then the interference is there, and that interference is going to introduce the noise, and that noise is going to completely vanish your system, and you cannot recover the signal if noise is going beyond the certain range. So, it is the selection of appropriate bandwidth that is going to help you for the selection of criteria. Now, the power level, as power level play a very vital role, because you know that at remote location you are using some kind of sensors, and if that sensors are using very much power, it means they cannot be work for the long period. That is also a point. And second point, as per the technical point of view, you have to maintain the power level low to reduce the noise, as this point come from the S by N ratio of the system, because you know that S by N ratio give us the noise introduction with the signal power, and if your noise have to reduce, your signal have to increase. To increase the signal to increase the signal to noise ratio, we have to decrease the noise, and for this signal to noise ratio you can use the various kind of power level attenuators or the system that are going to be used as the power level low to reduce noise. Then signal to noise ratio for the system must be high. I already told you that signal to noise ratio of the system must be high, as signal, if signal to noise ratio high, it means signal is high and noise power is low, because S by N is the directly ratio of the signal power to the noise power. It means signal to noise ratio is high, means signal power is high and noise power is low. So, these all are the main factors which going to influence the telemetry system design. So, before designing any telemetry system, it is required that you should point out or you should take consideration of all these factors for a telemetry system design. Now, the classification of telemetry system. This classification can be done on the various aspects, that basis may be a transmission channel, that basis may be a available signal or the signal output. So, that classification of telemetry system is going to be understood by these kind of channels, the basis. So, starting from the very first point, that is I already told you in the transmission part, transmission medium part, there are two types of telemetry system on the basis of transmission channel. First one is wire or wired landline telemetry system. Now, what is the point related to that? In wired or landline telemetry system, you are going to use whether coaxial cables, you can use optical fiber, you can use twisted cable, twisted copper cable, or any other physical wire or transmission line. Now, the point is here, these all are called power lines, electrical wires, telephone lines, and this type of basic telemetry, wired telemetry system having a range of 50 meter to 1 kilometer, because you have to establish some kind of physical construction between the transmission and receiving end, and it is required that you should maintain that particular physical, you can make the proper maintenance of that physical channel. That is why this range is limited between the 50 meter to 1 kilometer. Now, for the wireless medium, as when we are considering about the wireless medium or RF telemetry system, it means you are going to use radio frequency channel, and that radio frequency between the range of 20 kilohertz to 300 gigahertz as per the requirement. Means if you are using the satellite system or you are using the satellite telemetry system, this may be towards the gigahertz side, because in the satellite communication you are going to use microwaves. Similarly, it is also used for the range of 1 kilometer to 50 kilohertz, you are going to use that frequency of 4 megahertz. If greater than 50 kilometer, you are going to use microwave link, that is between 890 megahertz to 30 gigahertz, that is related to the satellite telemetry system, and that satellite telemetry system is the 5th unit of your syllabus. Optical fiber telemetry is also there. So, you can easily take out by here one point, that if 1 kilometer to 50 kilometer is range is there, you can use 4 megahertz signal, RF signal, or when it is about the greater than 50 kilometer, it is a microwave link of 890 megahertz to 30 gigahertz. Now, the use of repeater, this is also a very important part, that is repeater. Basically, repeater is a circuit which is going to reconstruct your transmitted signal. Now, question arises, why it is required? Basically, there is a transmitter and then there is a receiver. The distance between transmitter and receiver is around more than 50 kilometer, means 100 kilometers or 200 kilometers or 300 kilometers, and you know that as far as signal going to clear that place, or you are going to transmit that signal, after some time or after going through some distance, that signal introduced or interfered with some kind of noise, and that noise has to be removed time by time. That is why we are using repeaters at every 30 to 60 kilometer in case of long distance transmission. These repeater circuits are basically getting the data, receiving the data. That receiving signal is going to be filtered, means noise can be filtered, filtered there. After that, that signal is again amplified and then sent back to the receiving end. Means at the repeater, you are going to perform filter plus amplification. Filter plus amplification. You are taking the incoming signal, you are going to filter the noise from there, after that you are amplifying the signal and again transmitting back to the towards the next station, and it is required for the long distance communication. Now, no physical link between the telemeter, transmitter and receiver in this particular wireless. There is no physical link, it means maintenance requirement is low. Then example, if you are going to take the example, that example is satellite telemetry or another, in means in spacecraft, rockets, missiles, corrective action can be taken from station with the help of RF links, because in the spacecraft or in the rockets or in the missiles continuously parameters are changing, and you cannot directly control the points at the missile end or at the rocket end through directly. So, that is why it is required that telemetry system, so that you can take that data and you can act as per the data. Now, classification of the telemetry system as per the available signal, means which kind of signal you are going to be used in telemetry. If we are using a electrical signal, that may be analog or digital, but a electrical signal, it means that is a electrical telemetry system. But when we are talking about non-electrical signals, it means that may be a pneumatic signal, that may be a mechanical signal, displacement type of, or some kind of hydraulic. It means in the classification of the telemetry system as per the available signals, there are two kind of classification. First one is electrical telemetry, second one is non-electrical telemetry. In electrical telemetry, we are going to use directly electrical signal. In the non-electrical telemetry, we are using the displacement or the fluid flow or fluid pressure for this telemetry system. Basically, when we go deep into the study of this non-electrical and electrical telemetry, you can understand one point. In the non-electrical telemetry, all the parameters or all the quantities are in the form of physical quantities only, means flow, pressure or temperature. You are going to transfer these physical quantity directly. You are directly going to transfer the flow or the pressure, but in the electrical telemetry system you are taking any one of these physical quantity and going to convert this physical quantity into the electrical signal. This is our basic requirement. Now, as per the classification, the last part is on the basis of signal output. So, when we are talking about the signal output you can easily understand one point, that how kind of signal is getting at the ending point of the telemetry system. If you are getting a analog signal, it means that is a analog telemetry system. If you are getting a digital signal, it means that is a digital telemetry system. In the analog telemetry system, you are going to use amplitude modulation or pulse amplitude modulation, pulse position modulation, pulse width modulation or pulse telemetry, or in the digital telemetry system you are going to use this PCM, pulse code modulation telemetry system, in which what you are creating? You are creating a digital signal 0 1 0 1 0 1 from this analog signal. So, basically in the digital telemetry system you are performing or you are getting the digital output, that is 10 10 10 in the form of 10101. In the analog telemetry system you are getting a analog signal which is continuously changing its magnitude with respect of time, that is the definition of analog signal. So, this is the classification of various kind of basic telemetry system. So, you can easily understand that by this, that as per the classification we have various telemetry system. First one is transmission channel, it means that landline or wired or wireless telemetry system. That wireless telemetry system can be also from the long distance greater than 50 kilometers or through the satellites or something other. So, that is there. In the next part, that is electrical or non-electrical, and the third part is related to the analog telemetry or digital telemetry system, that is directly related with the part of signal output. If you are getting the analog output, means it is a analog telemetry system. So, now as per this classification we are going to study various kind of telemetry system in our next coming lectures. In starting with that, you can see that voltage telemetry system. Now, first of all, whenever you are understanding any telemetry system, first of all classify it. It is required because as per that classification you can design that system more effectively, more efficiently. So, when you are talking about a voltage telemetry system, first of all you can understand by its name, voltage means it is a electrical telemetry system. It is a electrical telemetry system. Now, how it is going to work? Measured variable is transmitted in form of voltage, means you are going to convert the physical quantity into the form of voltage, means if there is a change in the pressure, you are going to convert it into the voltage, change in voltage. If it means there is a temperature, there is a change in temperature, that voltage telemetry system is going to convert that change in temperature into the change in voltage. So, in the next lectures we are going to concentrate more all about these kind of telemetry system such as voltage telemetry system, then current telemetry system, and then its merits and demerits. So, in this particular lecture we understand about the factors that going to influence the telemetry system, then classification of the telemetry system, and in the next part we are going to discuss in very much detail about the voltage current telemetry, its merits and demerits, and non electrical telemetry systems. So, till now